Hello everyone and welcome to Infinite Limits. So here's a little vodcast. It'll be a quick one. There are really basically two cases that you'd really need to look at, the case on the left, case on the right. When you're doing an infinite limit, it's when x goes to infinity of, a statement like this or a statement like that over here. Okay. What you're going to do is actually, for a problem like this where there's a bunch of different ratio or fractions and all that good stuff, what you're going to actually do is you break it up into independent, almost like individual problems. 4 over x squared plus 1 minus the limit as x goes to infinity of 3x plus 2 over 4x minus 1. So I'm breaking it up into 3 different problems. Okay. Now, the rules for the infinite limits are the same rules as the horizontal asymptotes. What you do is you look at the numerator and the denominator, and you look at the degree of each of the numerator and the denominator, and you compare the degree of the x that is in each. Okay, the highest degree. So, for example, I look at the numerator here. I see that it's 4. There is no x, so I don't have a degree up here. I do have an x squared down here, so that means my denominator has a higher degree than my numerator. And when that happens, if you're taking the limit as x goes to infinity, the denominator is going to get really, really, really big as the numerator stays put. And so that means the denominator is getting huge, which when something over the denominator, over an increasing denominator, means the number is getting smaller and smaller and smaller, meaning it's approaching 0. So this actually comes to 0. Then we minus the limit as x approaches infinity of this. Now we notice that the numerator and denominator have the same degree, 1. Alright, so since they have the same degree, we take the ratio of the coefficients, just like we're doing the horizontal asymptotes. So my limit approaches 3/4. Plus, if you look here, 5x squared, 3x cubed. Cubed is bigger than squared, so denominator is bigger again. So this one goes to 0 as well. And then you add 0 minus 3/4 plus 0 is negative 3/4. And that's the answer to our original problem. That's it. Alright, just break them up in these different problems. There's one other case that I didn't put in this problem. I threw it over here. Is when the numerator is bigger than the denominator. When the numerator is bigger than the denominator, the limit goes to infinity. Okay? Because think about it, the numerator is getting a lot larger at a faster rate than the denominator. So it's just getting bigger and bigger and bigger and bigger, and it will never stop getting bigger. So this actually goes to infinity, and that's what you would write. There's nothing else to it, okay? So just remember, denominator bigger than the numerator goes to 0. Numerator equal to denominator, ratio of coefficients. Numerator bigger than denominator goes to infinity. Alright? Thank you very much for watching. Hope this helps. Peace!